So here we have question 6, which is integration and differentiation all rolled up into one big question. So let's get started with A part I. So let's find the gradient to the curve. Find the gradient, well, that is dy over dx. dy over dx. So let's differentiate this here. Y equals 12x squared minus 19x minus 2x cubed. So we know what to do straight away. We take 12 and 2 and times them together to get 24, 24x, and drop the power by 1, so it's x to the power of 1. Then minus 19 times 1 is 19, x disappears. Then minus 2 times 3 is minus 6, x drop down to 2. So find the gradient at point for the curve at the point A. So the point A has an x coordinate of 2 and a y coordinate of minus 6. So we're only interested in the x coordinate of 2. So let's substitute 2 into there. So at A, x equals 2, colon. So 24 times 2 is 48, minus 19, minus 2 squared is 4 times minus 6 is minus 24, and that is equal to 5. So the gradient at A, is equal to 5. Easy as that. Differentiate it and sub in the x value for the point you're looking at. Lovely. Right. Let's move it on to A part 2, or part II. Hence, find the equation to the normal. Now, make sure with this, be very careful you do not find the equation to the tangent. The equation of the normal is the line perpendicular to the tangent. So, the way we find out the gradient is we use this magic minus 1 over m, which means, okay, so the gradient at point A, we just found out, is 5. That's what it is, okay? So what we want is a line. Let's actually look at this. Let's draw a line that goes through there. So that line there, the gradient of that is 5. Now we want the normal. The normal means the line perpendicular to that. So let's draw something roughly perpendicular. That's roughly perpendicular. So we want to find out the gradient of that. And the way we do that, the gradient is going to be, so gradient of the normal, is going to be minus 1 over 5. So minus 1/5, or minus 0.2, whatever you like. So that's the gradient of the normal. And then we have our point 2 minus 6 is our point. So we have a gradient of minus 1/5, and we have a point 2 minus 6. Now there's two ways of working out the equation for this. You can look at it and say, look, we're at 2 minus 6, and we've got a gradient of minus 1 over 5. So we need to go 2 steps, because we're 2 on the x-axis, 2 steps to the left, and minus 1 over 5. So 2/5 up. So if we go minus 6 plus 2/5, then we get 28, or minus 28/5. That's what we get when we're at 0. So that's our y-intercept. And then we can write down our equation Get rid of this. Here we go. Then we can write down our equation. Y equals minus a fifth x minus 28 over 5. That's what we can write down legitimately. There is another way. If you can't do that intuitively, then there is another way which uses a formula which you will have seen before, or you should have seen before. Let me get rid of that there, that's in the way. So the formula is y minus y1 equals m x minus x1. So y stays the same. y1 is our y coordinate for point A. The y coordinate is minus 6. There we go, minus 6. So y minus minus 6 is y plus 6 is equal to our gradient, minus 1 over 5. Then x stays the same, and x1 we know is 2. So we put 2 in there. So minus 2, x1 is 2. There we go. And then we can times out the brackets. We go y plus 6 is equal to minus x over 5 minus or plus 2 over 5. Then here we go. We can take away 2/5 from both sides and get a y plus 28 over 5 is equal to minus x over 5. And what was the form they wanted it in? They wanted it in the form x plus p cubed plus y equals 0. They wanted everything on the left. So let's put everything on the left and get us some integers. So we'll times everything by 5, We're going to add this minus x over 5. We're going to add x over 5 to both sides. So we're going to get x plus 5y plus 28 is equal to 0. That's using the formula that we used up here, y minus y1 equals mx minus x1. We would have got exactly the same thing if we'd worked with this one here that we did intuitively, and we would have got exactly the same result at the end of it. So you can do it either way. I would say the intuitive way is better if you can do that. If not, the other way works perfectly well. So let's get rid of that working out there and that answer. Right. Next question. This is integration. This is designed to test your integration abilities. So we've got to integrate between 2 and 0. If you look on the graph, we've got to find out between 2 and 0. We've got to find out what that area is there. So let's ignore the 2 and the 0 for a minute. Let's just integrate as if there was nothing there. So let's integrate 12x squared, put a bracket on it, minus 19x minus 2x cubed dx. Don't worry about the dx, that's just, here we go. Look, this is opening the integration and dx is closing the integration. It's like opening and closing brackets. But anyway, you don't need to know about that just yet. So when we integrate, take the power up by 1 and divide by that power, like the opposite of differentiation. So take the power up by 1 is going to be x cubed. 12 over 3 is 4, so we're going to get 4x cubed. Then minus 19 over 2x squared. Minus 3 go up 1 is 4. 2 over 4, so minus a half of x to the 4. Half of x to the 4. So that's if we integrate it generally. Now let's bring back the 2 and the 0. So let's work out what x is let's work out what we get from this when we put 2 in as x. So x cubed is 8 times 4 is 32. So then we go to x squared is 4. 4 times by 19 over 2 is 38, so minus 38. Then 2 to the power of 4 is 16, over 2 is 8. So that's what we get when we put 2, and then we take away what we get when we put 0 in it. What do we get when we put 0? Well, this x is going to make it 0, this x is going to make it 0, this x is going to make it 0. Hey, we just got a 0 there. We can ignore that. So, what is 32 minus 38 minus 8? Well, it's minus 14. The reason why it's negative, we tried to calculate an area, right? An area under the graph. The reason why it's negative is because it's below the x-axis. So don't worry about it being negative. They've asked you, look, they've asked you, find the value of this. They haven't asked you what is the area. An area can't be a negative value, but they've asked you what is the value. Well, the value is minus 14. If you put positive 14, you'll actually lose a mark the way they've done it. I think it's a bit of a dirty trick, that, making you lose a mark for that, but anyway, got to play by their rules, not by ours. So we've got minus 14 as our answer. Let's get rid of all that. Good. So the very last question. I find these quite a lot actually now. These you get a triangle put in. I don't know if you can see that because I've drawn all over it, but if we go in here, we've got a triangle in there, in that kind of maroon colour. There we go. So that triangle there is the area of that triangle. Let's write a triangle. Our triangle is going to be 2 times 6 times a half. Because the triangle is height times base times half, and this side here is 2, this side here is 6. That's just given to us by a being 2 and minus 6. So the triangle is 2 times 6 times a half, which is 6. And remember we calculated the area under that curve? Well, the area was 14. The answer to the question was minus 14, but the area, because you can't have negative area, was 14. So we do 14, take away 6, and we get 8. 8 square units. Square units. You don't have to put square units, but it's just, you know, the correct thing to do, I suppose. So 8 square units, that is the answer to question 6. I'll see you for the last question, number 7.